I mean, like, they can't report me for using big words.
Hello and welcome back to Calculus 1 on this glorious Saturday. Temperature in 70s and... All right, let's talk antiderivatives, the reason why we all gathered here in such large numbers. The antiderivative is the opposite of the derivative. So, if you take the derivative of x squared, you will get 2x. The antiderivative states that if you integrate 2x dx, you will get x squared back, and we have to put this plus c at the end of it. Now the natural question should be, okay, as Brian put in, where the hell did you get c from? All right, so let's see. If I'm to take the derivative of x squared plus 10, what do I get? 2x. If I'm to take the derivative of dx of x squared minus 17, what do I get? 2x. Do you see that derivatives destroy this piece of information, that if you have this constant term added, it just gets wiped out, right? So if you just see a problem, you really don't know whether there was some kind of constant there or not, because this is going backwards, right? We know what the derivatives are, and we are going back, but every single one of those derivatives could have had, right before you did the derivative, it could add a constant. So that's the reason why we have this plus c. This plus c could be 0, could be positive 10, could be negative 17. We don't know. So that's why we put plus c. Mysterious, right? We don't know what it is. Now, to each formula that you learned and memorized for the derivative, there is a backwards formula for integration. So technically we are not learning anything new other than this plus c idea, because you all memorized that the derivative of a constant is equal to 0. Well, the integral of 0 dx is 0 plus that constant c, the unknown constant. The derivative of x to the n is nx to the n minus 1. The integral of x to the n dx. This is the only one that it's a little bit different. What's the derivative of e to the x? And what's the integral of e to the x? Plus c, okay. All right, very good. What's the derivative of ln x? One over x, thank you. So what's the integral of 1 over x? Ln x plus c. Yeah, you gotta chant that plus c, you know. How about sine x? What's the derivative there? And what's the integral of cosine x dx? Sine x plus c. Bueno. What's the derivative of secant x? Did you? Yeah, I totally ignored you. What's the derivative of cosine x? Very good. So what's the integral of sine x dx? Negative cosine x plus c. Bueno. So that negative has to stay around. Okay? Every single formula you learned, now you're doing it backwards, except x to the n. X to the n is the one that has a different formula because we do some simplifications in algebraic manipulations to make it look better. Let's see. Ooh, your favorite. What's the derivative of inverse tangent? You love this one. That was for tangent. What's the inverse tangent? Yep. So what's the integral of 1 over 1 plus x squared dx? Tan inverse of x
plus triangle.
No,
Of course.
No, my last class teacher had us call it Charlie.
Charlie?
Yeah, like plus Charlie, like that's
What kind of math class was this?
It's the Viet Cong.
Yeah, right. Oh god.
like we always be like
Was it a male or female teacher?
he was a male, he was like 87. He was actually like his name was Dr. Chow and he like
Oh, he was having flashbacks like that.
you know him, yeah, he always just do plus Charlie. Plus Charlie. So yeah. I don't know.
All right. So we're going to call plus Charlie or No?
Dude, I already get Vietnam flashbacks.
Vietnam plus? How old are you?
I was around before man created fire, or found fire.
All right. Good. So we're going to take a look at few very basic things about integration. So first of all, I'm going to put these things that you must have, which is integral, and then there will be something there, dx equals something there plus c. So must have the squiggly line, the dx, and plus c, all right? The functions go around it. We are going to learn next class exactly why we have to have all of these and what they mean. Today, I'm just telling you, you must have them as a notation. Other one is -1 per line per problem for whatever it's missing. So notation is extremely important, and they mean a lot of things. If you don't put plus c, the entire differential equations course goes down the toilet. Entire course. If you don't put plus c. If you don't have dx, your entire Calculus 2 class and Calculus 3 class are just gone. You can't perform in those classes almost at all if you don't understand and don't learn and don't get the habit of what dx means and what dx is and how to use it. So right now, they serve no purpose in our calculations at all because we are just reversing what we know. But once we give them meaning, hopefully you will see how important they are and what they do and so on. With that being said, let's solve some problems. First of all, if I have an integral and then there is some constant multiplied into a function dx, I can kick that constant out and just integrate the function. So if you, the same like derivatives, right? If you have 3x squared, you don't worry about that 3. You just take the derivative of x squared and you multiply with 3. So the same thing happens with integrals. If you have the constant, you kick it out, you do the integration, and then you multiply with that number. So I want to ask you now, what is the integral, and you have the formula up there, of 5x to the 4th dx? So what is this equal to? What are you going to do first?
Take out the 5.
Take out the 5. And now you will have to take the integral of x to the 4th. X to the... X to the 5th over 5. Very good. Hold on. So guys, it's either plus c or minus 1. You figure it out. Yeah. And then 5's die. So the whole thing is just x to the 5 plus c. I think for Charlie.
Yeah, what did you call Charlie? Like, what did you
She has a thing for Charlie. Leave her alone.
I don't know. He was like he's like a math genius. He like
Because
brought
Charlie's
all
in the
these
trees,
textbooks
so-
and he always referred to his kid as Charlie, so we all
Charlie's
call
in
him
the tunnel,
Charlie.
dude. Yeah, Charlie's in the tunnel, dude. Charlie pops out. Now you're like kind of like.
Integral of 4 sine x dx is what? Integral of 4 sine x dx is...
Because x plus c.
Negative.
Yeah.
So, what should I write? We kick 4 outside. So integral of sine is negative cosine plus Cecilia, which is equal to
Is she breaking your heart?
minus 4 cosine x. I gotta
Is she shaking your confidence?
find the new c.
Are you begging for please?
And there you go. I'll figure it out. Integral of 10 over x dx. What now? So plus 1 gets you... I know. I know, x to the 0 over 0, it doesn't work. High five? Oh. You got it? What is it? I'm interested.
It's 10 C ln x plus Charlie.
Perfect. 10 ln absolute x plus Charlie. I just need to make sure that I put this holy nightmare. I did not. It has to be absolute value. Go back to your formulas and find the 1 over x1 and put the absolute value there. Luckily, I'm still alive. And hopefully no one is watching this. Wow, one person is watching. Sorry, person. You have to have absolute values there, and I will eventually explain why and how.
Is it eventually yet?
Nope.
When will it be eventually?
Eventually.
Hold on, comrade, relax. The next part, important formula, is that if you have multiple functions added or subtracted, you can integrate them separately. We are going to have special formulas for multiplication and division, just like product rule and quotient rule, right? But if you have addition and subtraction, we can do each one individually. So if I have integral of f plus or minus g dx, I can do the integral of f and then separately integral of g. Now, you don't really have to separate them. This is more for purposes of the formula to show that they can be done separately. In the problem, we just do them, together. So let's say you have x squared minus 10 dx. All right, now this is a new thing that we should remember. I'll write it here in blood. Need these parentheses, because when I talk next class about this dx, I will tell you that this dx multiplies the function. So multiplies all of it, not just 10. So if you don't have parentheses, it will multiply only 10. With parentheses, multiplying the entire function x squared minus 10. So since this dx will be multiplication times, like dx, we need those parentheses there for notation purposes. So you're memorizing it now, but it will be clear next week, hopefully. So now we integrate these separately from each other. Integral of x squared is very good. And the integral of 10 is nice. And then plus c. Chamomile? It's a good tea, I know. Next one is Chipotle, right?
Yes.
There we go. Na zdrowie. Well, he spoke German, so I'm entitled to speak my language. Okay.
So we don't know what C is yet, right?
Well,
It's just C.
at the end of this lecture, we will see how to calculate C.
Okay.
All right. But when you do what we call indefinite integral, you just put plus C and you walk away. And if you have something that's called initial value, then you will use that to compute value of C, and we'll do those problems in like 30 minutes or so. So let's take a look at a bit spicier examples. So question is, how much is the integral of 7 over x to the 6 dx? Now I'll give you the hint. It says rewrite. Now, let's see if that helps in any way. So you should be able to rewrite this and then use one of the formulas that I listed. This is not going to use anything new, because there is nothing new. So, could I scroll up back up to the formulas? I can't. I'm sorry? I can. I said, do you want me to? I mean, you can also open the Google 4.9. You have it right there. I don't know. 4.9 section right after 4.8. And 4.8 is right after 4.7. 4.7 is right after 4.6. 4.6 is right after 4.5. I don't know where you're there.
This is way back to 3.7.
Yeah, so 4, yeah, I know. And I have nothing to do, so I can list them all. Actually.
I'm getting paid for it too.
So you're going to get a pencil, right? Model 3? No, S. 3 years. Model S.
Is that the one that's going to be affordable, or is that the one that's better?
35 grand, exactly. The first one. 3 years.
Oh, you're on the waiting list?
I was supposed to get it in 2 years, but I did it again. And I have to get another new physics part. Yeah, I know, but I'm really.
It's only $1,000 now, but I don't know if you can like get that back if you decide later to go.
No, I don't know. I think you have to pay extra for the steering wheel and stuff. I'm not sure.
Well, it's like they said, it's like 35 for the
So-
model, and then there's packages on top of that.
So dashboard comes. No stuff.
45th, negative 5. What is it? Oh, yeah, I know.
Sounds pretty good. Like, little robots inside to bring your groceries in for you.
Well, they have that robotic arm now that they did for fueling.
Oh,
So I've seen that one. They had a little video of it. It's so pretty. You see the car closing on its own in the garage, and the garage closes on this little arm. And the cap opens for the gas tank, and it goes in the car.
Don't do anything.
Well, they have the new feature now is that the car opens the door. No, the car opens the door for it because that's the key. So if you are approaching the car from the back, right, on the driver's side, when you are somewhere by the gas tank, the front door just opens and you walk in, and as soon as you put the door shuts.
forget all that though. Safe as a car.
Well, you have got light. You only need one.
You don't need lights. Your lights are like not necessary now.
Yeah, because that's what happens. The car is the fun.
All my neighbors are like,
And that's how Skynet begins.
I'm ready for our overlords.
So we are going to kick 7 in front of the integral, and we are going to write x to the minus 6 dx and use our integral x to the n formula. Very good, Brian. So this becomes 7 x to the minus 5 over minus 5 plus c.
Plus condom. Or chameleon.
Chameleon? Okay.
No, because it's hidden and now it's revealed itself. Infinite C words, that makes sense. Better than some.
So we have negative 7 over 5x to the 5 plus c. Next one. What is the integral of the cube root of x squared dx? Please enlighten us. I say please enlighten us. I don't either, but sometimes in life you just have to do it. Let's see if anyone likes me. Hey. Yes.
I like you.
No. All right, so let's take a look. What should I write this as? Integral of
X squared to the 1/3.
x to the 2/3, yes. Dx, which means it's x to the 2/3 plus 1 divided by 2/3 plus 1 plus c. So the entire thing is now x to the 5/3 divided by 5/3 plus c, and then to solve the double fraction, it's 3x 5/3 over 5 plus c. All right. Now there is one enhancement formula which we are actually going to fortify a lot in your 5.5 by using u sub. They are asking you now to memorize for a short while and then later on do it the right way. And that is that if you have integral of e to the ax dx, you are getting e to the ax over a plus c. And if you have integral of sine ax dx, you will get negative, oh, so we have negative 1 over a cosine ax plus c. So you see that there is this over a thing going around. And also for the cosine, right, ax dx, you will just have sine ax over a plus c. So these are the formulas. You will know how to do these without, memorizing these formulas in 5.5. But for the purpose of the next test, you might want to know this if you choose to have a test, obviously. So what is the integral of e to the 5x dx? Yeah. So that over 5 is there. How do you know? Do you read minds or something? The next part of this lecture is how to check if your answers are good. And we do that by taking the derivative. So, one great thing for me in mathematics is when I can check the answer and know that it's right. Because we have to face it, your feelings and your opinions do not matter at all. You heard me say before. This is mathematics, and there is 1 plus 1 is 2, and you just don't matter in any aspect of it. So, I know, right? Which is why you're having such a high grade. I know. Imagine if I could just base it on my opinion. All right. So here it is in red. To check the integration, we take the derivative of the answer. And I'm going to write this as a formulas, but we're going to deal with this obviously with examples as well. So if I do integral of f of x dx and I get some f of x capital, we call that antiderivative, plus c, then the derivative of capital F of x plus c will be the little f of x where you started from. So I did this earlier with the x squared, but I did it backwards. So now if you have integral of 2x dx, you are integrating this as 2 integral of x squared dx, which is 2 times x squared over 2 plus c, which is x squared plus c. And now to check, you will take the derivative of x squared plus c and get 2x plus 0, which is 2x. And hopefully you can see that this 2x was there. This is why there are no excuses for you not doing this right. If you are interested at all, if you care about this at all, you will quickly take the derivative to make sure that you are doing it right. The same thing like when you're solving an equation. You have equation x plus 3 equals to 5, and you come up with x is equal to 2. Well, plug it back in. 2 plus 3 is 5. 100% correct. So it boils down to, you know, caring and not being lazy, technically. That's it. Every integral, Calc 1, Calc 2, Calc 3, can be checked by differentiation if you get the formula you started from, right, like 2x in this case, it is correct. If you get anything else, it's wrong. That's simply as it is. So that's that. And the last part is to figure out the value for c. So let's call it find Charlie. Like Finding Nemo, except this is Charlie. So that plus c thing, right? I know, I just can't shake it off. That's it. Changed me forever. So now I'm going to say I want to integrate 2x dx with f, just relax, with f of 2 is 5. So this portion here is that extra piece of information that we need to find c. So you will do your integral regular way, right? This is equal to 2 integral of x dx, which eventually works out to be x squared plus c. Now, you are going to say, right, 5 is equal to 2 squared plus c. Because the entire function is equal to 5, that's like a y value, x value is 2, and then you only have one variable to compute, which is c. So in this case, c is equal to 1, and we have the answer x squared plus 1. So the only way to retrieve the original value for c is to have what we call initial point, initial value. Now, we need to, well, some of you might need to understand what this actually does. I'm going to go back to pre-calculus 1 and remind you that if you have f of x plus c, this plus c shifts function up and down depending on its value. Positive c is shift up, negative c shift down. So shift up / down depending on whether it's positive or negative c. Now, for our problem, which said x squared plus c, if I am to graph this, I will have to graph infinitely many of these parabolas because they have to go through every value on the y-axis. Every single one. So this over here is a family of infinitely many parabolas stacked on top of each other because we don't know where is the c. However, when you provide me with a point 2, 5, that point is going to single out one of these. Which one? Exactly the one that goes through 1. Because that will be the only one that will go through 2, 5, which is what we had as initial condition. 2, 5 can also be written as f of 2 is 5. This is the way to write the point in terms of a function notation, or you can write it as a point. It's xy. So, any time when you get this plus c, that plus c has infinitely many functions stacked. You can have ln x plus c. ln x plus c is going to stack infinitely many of those. Any single answer that we had today in this lecture for any of these problems, this plus c was stacking infinitely many of those functions on top of each other. X to the 5, infinitely many on top of each other. Negative cosine x, infinitely many, and so on. To single out one of them, you have to have this extra point. Now, that extra point you usually get through observing something. Let's say, you're talking about the oven temperature or cooking a turkey, and then you want to check how much longer you have to cook, and you have a formula for that. When you do the differential equation for it, you will have this plus c. You have to take a single temperature reading of a turkey. And that reading that you say, I cooked it for an hour, so T equals 1, and the temperature, capital T, is equal to, let's say 91 degrees, you use 1.91 as a point, and you figure out the value for C. And then you have a function. And then you plug in the temperature value, target temperature value for turkey is 160. By the way, that's how I cook. And I crank differential equation every time. And it reduces a lot, trust me, less stress. And you get, I actually computed this recently, well, the last Thanksgiving I computed it, and I got perfect time for the turkey I had in the oven I used. It was something like, I computed down to a second.
Was it delicious?
Of course. He has to. And I also had the argument with the members of the math club from before. There was a cool bacon wrapped turkey. Like, you take the entire turkey wrapped in bacon. It's not going to work. Because the latent heat of the bacon and the latent heat of turkey are not even close. So, do a little bit of math. By the way, there is in one of the cookbooks, there is exactly latent heat for every single piece of food that you would process in the oven. So you can do differential equation upon anything and make it work. So, I was considering switching careers.
Yeah, now I am.
So, it's all math about cooking. It's like conversions of units and so on. And then, when the stuff is going to expire, that's also the dates and time, that's numbers, and then cooking times and what works. You can't wrap turkey in bacon. That makes no sense because the baking of that would just be terrible. Unless you cook the turkey for about 47 minutes, then take it out, then wrap it with bacon, and then put it back on, then you get something done. But I'll leave those calculations for one of the projects eventually. Well, my Calc1 project problem from 3 years ago was cooking the chicken. And actually students didn't send me the photos a week before. they gathered in a house of one of the students. Like 4 of them were cooking the chicken. It was 2 a.m. The the timestamp on the photo. 2 a.m. They're baking chicken, doing the math problem. It was epic. You see, the kitchen, everything is in disarray. There are papers everywhere, waiting for the chicken to be done, so they can check if their calculations worked out. Worked perfectly. Plus, they had an awesome meal. And you know what? I mean, you can't replace that with anything else. There's 4 people, right, together, 2 a.m., right? They invested $6 into chicken, and like spread that towards 4. That's $1.50 each. I mean, come on. And few hours of math and fun and food. I'm proud of what I bring to you. You know what I mean? Which is why I'm not a cook. I still do this. And yes, I deserve the raise.
Did you tell math department that?
I have nothing to do with it. Okay, well, I mean, we're done. Could have stopped streaming before the story, but that's okay. Now the world knows how important I am. Exactly. All right, bye, guys, and I will see you next week for Chapter 5. Oh, no, you stay. You have lab to do. What the hell? Exactly, no coffee.